Bismillahirrahmanirrahim. Dear students, this is your physics third lecture of online class in which we have discussed the new topic, that is radioactivity, from our new chapter, that is chapter number 18, nuclear physics or radioactivity. From book page number 236. The radioactivity is the spontaneous release of subatomic particles or gamma rays by unstable atom as their nuclei tend to break apart into other particles. To attain this stability is called radioactivity. And the elements which possesses such property or which emit the radiations are called the radioactive elements. As we have discussed in our last lecture, that is, the nuclides are the nuclei which have the same number of protons and neutrons, while the unstable nuclides are some nuclides which are unstable in nature, and in order to attain the stability or to become themselves stable, these elements emit radiations. And these radiations are of three types, that are alpha, beta and gamma. The nature of radioactivity was discussed by the Ernest Rutherford, and he told us that it is possible to distinguish these three forms of radiations using the scheme shown in the figure. The radiation from a radioactive sample, and he took a sample of radium which is directed into an evacuated chamber. The evacuated chamber means the region from which the air is pumped out, in which there is a magnetic field, and here these cross marks shows the magnetic field which is directed into the paper. The image on the photographic plate shows that the beam of splits into three components, the two bending in opposite directions and the third experiencing no change in direction. By using the force on charged particles in magnetic field, we can conclude that the radiation of undeflected beam carries no charge, that is the gamma rays, while the component deflecting upward consists of positively charged particles called the alpha rays or alpha particles, and the components deflected downward consist of negatively charged particles called the beta rays or beta particles. The similar observations can be made by passing a beam emitted from radium through an electric field placed perpendicular to the beam as shown in the figure, in which we have the two electrically charged plates, positive and negative. The radioactivity is seen in this figure due to the electric field. Then the two deflecting rays alpha and beta strikes on the photographic plate, while the undeflecting ray are the gamma rays. This is the radioactive atom which emit the radiations, and a huge amount of energy is released by the emission of subatomic particles. In alpha radiations, the emitted particles are 4 helium nuclei. It means the alpha particles have 2 protons and 2 neutrons and have positively charged, and its effect is on the parent nucleus is it loses mass and the new element will be produced. While in beta radiation, the emitted particles are either electrons or positrons. Positrons means the positive electrons, and it has the negative charge -1 and no change in mass when it emits from a radioactive substance and the new element is produced. In gamma radiation, the rays are highly energetic electromagnetic radiations and have no charge, but the huge amount of energy will be lost. The radioactivity occurs without apparent external cause and cannot be speeded up or slowed down by physical or chemical means. Radioactivity is a process which occurs randomly without defined pattern, rule or method. Here another radioactive element which emit the radiations by the emission of energy and the subatomic particles. The individual disintegration occurs randomly, so radioactivity cannot be predicted because the precise moment of disintegration is not known for particular nuclei. It can emit the radiations after a few seconds, after an year, after an hour, after 10 hours. So there is no disintegration, individual disintegration occurs randomly. Now we will discuss the nature of emissions. So all the three kinds of radiations have different nature. The alpha emissions, the alpha particles are helium nuclei, as we have discussed that the two protons and two neutrons bound together, emitted from the nucleus. When the ratio of the neutrons to protons is too low, then certain atoms restore the balance by emitting alpha particles. So if the neutron to proton ratio becomes too low, then there is an emission of alpha particles. While the beta particles consist of electrons emitted from the nucleus, so emission occurs when the ratio of the neutron to proton is too high. In this case, an excess neutron transforms into a proton and an electron. The proton stays in the nucleus and the electron is ejected energetically. In gamma emissions, the gamma rays are electromagnetic radiations emitted from the nucleus, and the gamma rays emission occurs when the nucleus of radioactive atom has too much energy. As a result, the gamma radiations will be emitted from the radioactive substance. Now we will discuss about the relative ionizing abilities. So the phenomena by which the radiation can split matter into positive and negative ions is called ionization. All the three types of radiations, alpha, beta and gamma, have quite different ionizing abilities in air. Alpha particles ionizes air much strongly due to its large mass and charge than beta and the gamma radiations. While the gamma radiation has the least ionizing ability as compared to alpha and beta radiations. The relative penetration abilities, the penetrating ability is how deeply a radiation can go into a material or how much distance the radioactive element will cover. All the three types of radiations, alpha, beta and gamma, have quite different penetrating abilities as well. As you can see in the figure that the alpha particles barely penetrate a sheet of paper and has range of no more than a few centimeters in air. As you can see that the alpha particles will penetrate through a paper. In this figure, while the beta particles cross through the paper and penetrate into the wood, and the gamma radiations cross the paper as well as the wood and strikes on a concrete block and penetrate into it. In this figure you can see that the alpha particles will penetrate only by a human hand, while beta particles cross the hand and penetrate into an aluminum foil, while the gamma radiations cross through the hand as well as the aluminum while penetrate into the lead. This figure is also clear that the alpha particles will penetrate only on paper, while as compared to the paper, the beta particles cross through the paper and strikes on the hand, while the gamma radiations cross through the paper as well as the hand and penetrate on a concrete block. So it means the beta particles can penetrate a few millimeters of aluminum, has range in air of about 1 meter. And the gamma rays can penetrate several centimeters of lead and has an infinite range in air. We can also say that the alpha particles can be easily absorbed by our hand, whereas the beta and the gamma radiation will pass through it. While beta radiations on the other hand will be easily stopped by concrete block, whereas the gamma rays will travel few centimeters before absorbing in concrete. So these three figures shows that the gamma radiations have the more penetrating power as compared to the beta, and beta has the more penetrating power as compared to the alpha. I hope you understand each and everything very clearly. So till the new topic, Allah Hafiz, stay home, stay blessed.